In this part, I will explain how to install external packages, which we haven't done at this point, to be able to access both data and functions that will ease our workflow. I will start by using the install packages function, install.packages, and in quotes I will type trace statistics. This is a package that I created a while ago to access a website that contains international trade data. And from there I will obtain imports and exports, and I will combine this with another data package, which is a CP geodist that contains distance between countries, borders, contiguity, common language, common currency, etc. In addition to that, I will use another package that's fixed, and that package provides functions to estimate GLMs, and this package it's especially relevant when we need to estimate something with a large number of fixed effects. So now I will proceed to install the package cpgeodist. Besides installing here in the console, this is something I need to do one time and one time only, except if I want to update the install package. I don't need to run the install packages function in my scripts. That's why I run this in console. But I can also go to packages in the right side of RStudio and click on install and search for a certain package. So here I will look for fixed, and that's it. And that's another way to install, and in the end this also calls the install packages function. So what I wanted to say is that I don't need to create a new file. Let's say that this is a script where I put my analysis. I don't need to type the install packages function here and install every time. So for example, I can put that here and leave that commented, right? And insist on the idea that this is a one time only. And the same for the other packages. So we install fixed. Before that we install cpgeodist to obtain data, and trace statistics also to obtain data. The difference between cpgeodist and trace statistics is that trace statistics downloads the data, and cpgeodist already comes with the data readily available, and that's because of the volume of the data. So now we call these newly installed packages. We call fixed. We also call cpgeodist, and we also call trace statistics. So we put those in memory with the library function. This is a bit different than the workflow in Stata. I know that. I learned Stata initially, and now after we load these packages by calling the library function, we can access the functions and the datasets contained within each package. So now I will proceed in the following way. Number one, I will create a dataset with exports and distance, contiguity, and former colony, just to provide an example. So I need to divide this in two steps. 1.1 and this step will be about downloading trade data. So here is where we use the trace statistics package. So we will create a new object or a new table, and the name will be trade, and we use the OTS create tidy data. So here, let's say that we want data from 2015 to 2020, and for the reporters we want all countries. For the partners, let's say we also want all countries, and for the table we want aggregated flows. That means the aggregated number of the total exports and imports that were sent from one country to another one. We don't want the product disaggregation here. And for this case, the table is the YRP. And if I search for the function name and I go to help and I type OTS underscore create, and then the autocomplete suggests the function. Here I have access to a complete explanation of each parameter in this function. And if I go to the end, I can go to the index of this documentation and I can read a complete documentation for this package. There's also a user guide. I can click here, and there's a tutorial included inside the documentation that covers each aspect of this package. So now we go to the end of the line and hit Ctrl Enter or CMD Enter if I'm using a Mac, and this will download all the data and put all the years combined in a single table. And that's it. So here I have the year, reporter, partner, and the imports and exports. So now comes to item or point 1.2, and this will be combining trade with additional variables, and these variables come from CP_DODist. So now we can copy the name of this table, and we are not going to overwrite the table right now, and I will insert a new operator that we haven't covered, which is the pipe Ctrl+Shift+M or CMD+Shift+M, which allows me to concatenate operations. So instead of running a long statement, let's say that I want to filter something here. Let's say I want to filter and keep all the observations for exports that are greater than 0. I do that, and then I can concatenate this and then include another operation. And why it's important to concatenate? Because I can do this, and then let's say that I want to create a new column, and here I can create a column, let's say log of exports, and this can be log of the previous column. The alternative to this will be something like let's say I filter first, and then on a separate operation I create a new column, right? So I prefer this syntax. It's something that in my opinion it's more readable. It's better than doing something like let's say trade and then subsetting here and putting something like by rows, not by columns, something like trade and then go to the column and then put greater than 0 and then put this in a new table. And then besides that, let's say we put this in a new table. Then besides this, I will need to use the $sign again and create this new variable. So these two lines that I have here can be combined into a concatenated statement, and that's why I like this approach, the first approach over the second. So now we can comment this. It's the same. And I will save my changes here, right? So here I have just realized that I haven't opened a project. So we will review something that we covered before. So I will just select everything in here, copy, use this package, and I will create a project. So I will open quotes, and here I will type home/github/YouTube codes, and here I will create inside the linear models videos. I will create a new project, and the name will be part 3. My previous code is already copied and it's in the clipboard, so I can paste that there later. So I will create my project and proceed. So now I can either use this and use our function from the previous parts, and let's save this as FE poise example, because we will be using a fixed est function that's meant to fit Poisson models with fixed effects. That's why the name FE poise. So now we paste the previous code, and now we save it. And that's it. So I will run everything, but this concatenated operation won't work. Why? Because we need to load another package to be able to access the pipe that allows us to concatenate and to use filter and the mutate function. And to avoid any confusion between log and exponential, we will call this exports. We go to the previous part, and now we repeat a bit. We don't need to install the package every time that we run the script, so we leave that commented, but we put that anyways. We comment that we need to install the deployer package, and now we type here deployer. I have already that installed. I use that every day. Otherwise, you just select that line without the comment and hit Control Enter, or go here to packages, then install, and then search for deployer, and then you click install. I won't do that because I already have that installed. Okay, so now we select all the code that we have up to this point and hit Control Enter, or just run to execute the selection. So what happens here? In this code, every time that we run this again, we will download the data one more time, and we can avoid that. How? We can create here a new object containing a text string or a character, and we will call this thread 1520.rds. RDS is R's native format, and this is preferred over CSV, let's say, because it preserves the column structure, so it indicates when a column is an integer or a double or something. So now we proceed here, and now we can do something to indicate R, not to rerun the download when the file exists. So we type if. So if we put if, file doesn't exist. So we put negation, file.exists. That means file doesn't exist. And we type f out. Then we open curly brackets. And now we close the brackets. And now if we copy and paste this will auto indent. That's it. So now if we run that selection, it will run again. Why? Because the file was not saved. So now we, inside the if statement, we type save RDS. We put the name of the object, which is trade, and then we put the name of the file to save this. So we put f out. So now we can just run the save part, and it will be saved in the root of the project. So now we can run the selection again. We don't need to run the f out line a second or third time. This is already in the environment. So I will run the if statement once again, and that's it. So it doesn't re-download the data. So now we have that ready. And then what happens if we run a new session? So we need an else part. Otherwise, what happens if I restart the session or I just hit the room here and clean the memory? If I run up to the if statement, let's run this, I won't have the trade table. So I need to write an else part, what to do when the file exists. So here I type this, I type trade arrow read RDS, and here I read the file. So now I can go to the end of the if else statement and execute that with Ctrl Enter or CMD Enter. And now this reads the table again from my computer and doesn't download everything a second or third or 99th time. So now we can proceed and show this example. So here I can filter and create a new column. So if I run that change statement, this creates a new table that has around 130,000 rows, right? Versus 160,000 rows in the original table. So we can now format this a bit nicely. This is a difference between our formats. So we can stick to the table format here instead of the data frame format. So if we do that, now this is nicely displayed. So now we can save this. Let's say as Track2. So now we have a new table here, or we could have replaced the original table by just overwriting to trade. So now we need to combine this. So now we type Track2, and now we can hit Ctrl+Shift+M and run an inner join with one of the tables in the cp-geodist package. So here we have a dist cp table. Let's explore this table. And this table contains origin, destination, and then the different variables. So here we need to be careful because the origin and destination is in uppercase, while in our table with the exports, this is in lowercase. So we can also conduct a few additional operations. So now we can expand our mutate, and we can create an ISO O, same as the distances dataset. We can set an origin variable, and because distance and common currency and that type of variable is symmetric, we can set the origin to be the minimum between the exporter and the importer. So to do that on a pairwise basis, like a first row, we take the two countries that appear there, but on the trade table, we take the Emirates and Aruba, and then for the second line and the third line and the fourth line and so on, we want to take the minimum on a pairwise basis, and R, for example, between Argentina and Aruba, can also take the minimum for text, and does that by alphabet. So it sorts by A, then B, then C, and so on. So to do that, and do it like line by line, like line 1, then line 2, and then line 3, and get the minimum per row, we use the pmin function, and here we put reported ISO and partner ISO. And then for the destination, we will get that as the maximum. We do the same. And now we run our change statement again. And now we have our tables here. We can expand the object that appears in the environment, and here we will see that we have the ISO O and D. And we can conduct yet another operation, which is to put this in uppercase. So we use to upper. So here we see this is in lowercase, and now we type to upper. And now if we explore that, we have the countries in uppercase. So now we can match the two tables between in R. It's not the same to put, let's say, Emirates in uppercase or lowercase, or Argentina in uppercase or lowercase, or any other country. So now we can conduct an inner join, and we don't really need to call the package on the left side of the table. We can just call the table by name, and we can select inside the inner join here we select the distance, the colonial history, colony, and we said that we were going to include the contiguity, which is the contig variable. It is important to mention that the inner join, unlike the left join, keeps the intersection between tables. You can read more about that on the R4 Data Science book that I will include in the description. So here it says that we have no common variables, right? And this is because we forgot to include the ISO O and ISO D in the distances table. So when we do this, we see that the number of rows got reduced because not all countries from both tables are present on each table. So here we see that the distance, colony, and contiguity was appended to the trade table. So now we make this permanent. And now we have the distance, colony, and continuity, and we can see that in the environment. So now we are in conditions of fitting a linear model. So we had a first step to construct the dataset. And here we can add 4 dashes to be able to navigate more easily and explore the sections in our code. So now we proceed to step 2, which is to estimate or fit a boson model with fixed effects. And same as the previous step, here I will go by parts. So first we can estimate a boson model without fixed effects. So here we use the FE voice function. And here we can use any of the columns from our dataset, but here I will type call names to see all the columns in the dataset, and I will copy the exports column and fit this with distance, continuity, and colony as explanatory variables. And for the data I will pass trait 2. So now I have a first estimation. I can also alter this and use imports as the dependent variable. And if we compare, the coefficients are not that different. Okay. So now we need to pass the fixed effects. So how do we do it? So this will be 2.1. Estimation without fixed effects. So now we create new columns or variables to add the fixed effects. So here we will add the fixed effects by year and exporter. So how do we do this? We call the Track2 Table, insert a pipe, and now with a mutate we can create something like, let's say, FE exp, and here we can paste with paste 0 without spaces. We can paste the reported ISO and the year. And we can add another type of fixed effect. We can also add fixed effects by importer. So we can copy the same, comma, and alter this slightly to have the importer and the year as another fixed effect. So if we do this, we can make the change permanent. So what do we have here? So if we explore, we have reported ISO and partner ISO, not importer, so we fix that. And that's it. So now we can run a glimpse to see the table. And here we have the fixed effects by exporter, importer, and year. So now we can copy the previous model. And now we set this as an object. And here we need to pass the fixed effects with a special symbol. We will move the data to a new line, and here we add the OR operator, which in this case means to pass the fixed effects. How? We put here FEXP and FEIMP. And that's it. That's how we add many fixed effects. So now we proceed to estimate this. And now we can get a summary. And that's it. So we have the slopes for the distance, contiguity, and colony. And in addition to that, we have a large number of fixed effects, right? So if we sum the exported fixed effects and the imported fixed effects, we have around 2,000 specific fixed effects. That's how we do it. You can compare with the GLM function, and you will see that when you have a large number of fixed effects, this solution is more efficient in terms of fitting time. So that's it. So now we can even save our model. The exercise for you is to include the if-else statement as the previous part. In case you don't remember, it's this if-else. So please create something similar so that you don't resave the model when it's not required to save many times. And there we have the model, and now we can access our save model when we need it. That's the end of the third part. In case of any questions, please email me or leave a comment. Thank you.